नहीं लोग है, but I'll wait for another 4 minutes. 9:40. ठीक है? Then we'll start. Prathamesh, you can start your uh, presentations at 9:40. Okay, let's wait 4 minutes. Maybe
Okay, sir.
I am not sure, but for some reason people are not there. Okay. Prathamesh, you can start.
Yes, sir. So is the screen visible?
Not yet. Yes, now it is.
Okay. So yeah, good morning all. My name is Prathamesh, and today's my topic is API/IPA and loopback address. So first, what is API/IPA? So API/IPA is called automatic private IP addressing, and it is a feature that allows devices to assign themselves an IP address in absence of a DHCP server. So API assigns IP address from a predefined range of 169.254.0.1 to 169.254.255.254, or we can say 169.254.0.0/16 block. Devices that use the API address use the subnet mask of 255.255.0.0. So in IPv6, the IP address is the link local address with the prefix FE80 ::/10. Means after FE80, all there are all zeros in that address. So this is the working of API. We'll go into the detail in the next slides. So the first is device initialization. So when a device or a such as computer connects to a network, it attempts to obtain an IP address from a DHCP server. So if a device cannot reach the DHCP server, or the server fails to respond, the device recognizes that it can obtain an IP address through usual DHCP process. So this could be due to many reasons, such as network issues, misconfigurations, or absence of DHCP server on the network. So uh, the next is API activation. So in absence of DHCP assigned IP address, then the device activates API as a fallback mechanism. So API is typically enabled by default on Windows operating systems. Uh, the next is when then IP address assignment. Then the device assigns itself an IP address from the reserved IP address range of 169.254.0.0/16, and it randomly selects the IP address from this range. Uh, then subnet mask configuration. Uh, s- the device then gets a subnet mask of 255.255.0.0, indicating that all IP address within the 169.254.0.0 range are part of the same local network. Then what it does is the address conflict detection. So to avoid IP conflicts within the local network, it performs uh, conflict detection using mechanism that is called gratuitous address resolution protocol. So in this, the device sends ARP request to check if any other device in the network has the same IP as it. So if it has, then the device repeats the IP address assignment process and obtains again a different IP address. So in local network communication, so when the IP address gets assigned, the device can communicate within the local network range with the other devices which has other API addresses. So, but the API addresses has limited internet connectivity, in which we cannot communicate to larger networks, uh, and we can only connect to the local networks, and we can connect, or we can say uh, access to the broader internet is possible through getting a valid IP address from a DHCP server only. So uh, time limited lease. So when API address is have a TTL of only 24 hours, after this period, the device will attempt to obtain again a proper IP address from a DHCP server, providing a more stable and long-term network configuration. So for troubleshooting API, so if a device has API-IP address, but it needs to connect to the broader internet. So this typically indicates a problem. So common troubleshooting steps that should be taken can be checking the connection to DHCP server, verifying that the DHCP service is running and properly configured, ensuring there is no IP address conflicts, and restarting the network devices, including routers and switches. So the next is loopback address. So the loopback address is a special IP address which is used by a computer to refer to itself. So it is mostly used in networking for testing and troubleshooting network configuration, applications, and services. So in IPv4, the loopback address is 127.0.0.1. Uh, it is the mostly used loopback address, and any IP address in the range of 127.0.0.0 to 127.255.255.255 is reserved for loopback purposes, but 127.0.0.1 is mostly used. In IPv6, the loopback address is represented as ::1, means before one, all there are zeros in the address. So the purpose and function of the loopback address is used by hosts to own its networking stack, network interface or services without sending traffic over the physical network. So it provides applications to communicate with one another locally without needing an external internet connection. So this address can be also used to test the networking software even if the machine is not connected to the network. So a loopback address functions by redirecting the send packet to the host, and the local network of the host, the local network stack of the host processes it as if it came from another device, but without the data ever leaving to the host. This mechanism is crucial for testing and debugging network configurations and applications. The use cases are we can use for the loopback address for testing local services, where we can test local web servers, databases, or other services by pointing to 127.0.0.1. Then we can use it for network troubleshooting. So the command ping 127.0.0.1 is commonly used whether the device TCP/IP stack or are properly configured and functioning. If the ping is successful, it means that the networking software on the device is working correctly. It is also used for internal communications, like the application running on the machine can communicate by a loopback interface, which is more faster and efficient than using the actual network. So the limitations of the loopback addresses are that loopback addresses cannot be used to communicate with other devices on the network or over the internet. They are strictly used for local communication within the same machine. Uh, and because the packets, the next is because the packets never actually leave the machine, you cannot use loopback addresses to test external network connectivity or diagnose issues with network interfaces. Thank you.
Okay. Thank you, Prathamesh. Uh, just a small feedback, a little less theory, okay, or either replace it with the diagrams or pictures, okay.
Oh.
Okay, so that's your
Mm.
pipa and loopback. About your other two, forwarding based on label and IPv4 versus IPv6, what's the status on that?
Sir, I have done, I guess, the label-based forwarding I have done, and IPv4 versus IPv6, we have to create Word document, no?
Yes, as an alternative.
I
Is
have
it ready?
created Word. Word document for that.
So send that on mail. I mean, send
Yes,
everything
sir.
on. I think I have your mm, Apipa, and just a minute, I'll check my mail. Prathamesh. Yeah, I have your doxes and Apipa look back. So your um IPv4 versus IPv6 is missing, and forwarding based on label is missing. So you send those two on mail, and uh, in a few minutes, okay, maybe at the end of the lecture or sometime, you present the forwarding based on label. Okay.
Okay. So should I start?
No, no. We'll take it in some time. You just send it over mail for now.
Okay, sir.
All the things. Okay. Just give me a minute. Is my screen visible?
Yes, sir.
Yes, sir.
Okay. Ashay, Prathamesh, Shrecha, Mamita. Okay. I think Shubham was there, right? He seems to have left, so no attendance. Ashay, Mamita. Okay. Ashay, see the recording of yesterday. Okay.
Okay, sir.
Yeah. For others, right? Yesterday, we just saw the working of. We saw the working of ARP. ARP is address resolution protocol. Okay. What it does, it's maps IP addresses to MAC addresses. This is IP is to find where on the internet, MAC is to find the exact device ID. IP is provided by the ISP, Internet Service Provider. MAC address is provided by the manufacturer. Okay. So when sending this IP, we need in the network layer, and MAC address we need in the data link layer. Okay. What ARP does is, ARP's job is to find out what the MAC address is. Okay. MAC address of where he wants to send the data. MAC address of where the data needs to be of the device to whom we are going to send the data. Okay. Shubham, I haven't received any of your forwarding based on label or IPv4, IPv6 assignments. I think.
Sir, today I will upload.
And what about the presentation? I only have Toxis. I don't even have the Apipa and loopback. And accordingly, I don't see you have presented either. I'm since 14th, I think was the last. 8th I had given. So that's 2 weeks. 3 assignments. Never mind. It's not right to others, right? Who do it on time and submit it on time. It's fine. Anyway, let's continue. I am going to mark it as at not submitted. Okay. 2 weeks is too much time for 3 assignments, and it's unfair to others who have submitted on time. Okay. Right. So then we come back to DLL. Okay. So data link layer, we get the MAC address. Okay. If you remember, at that point, the message is sent to everyone in the network. And that time the MAC address when sending it to everyone is all Fs, right? The message goes to everyone. The person who has the particular IP address says that, yes, I have it. Here's my MAC address. That address is put back in the original packet and the packet is sent. Okay. Those who attended yesterday, I hope it refreshes your memory. Let's go through the theory part once again. Okay. So ARP stands for Address Resolution Protocol. It is a network protocol used to determine the MAC address from an IP address. In other words, ARP is used to mapping the IP address into MAC address. When one device wants to communicate with another device in a LAN, local area network, the ARP is used. Again, this point is very important. This is only for LAN, local area network. ARP does not work in WAN or networks that are higher in it. So when we are communicating over the internet, okay, या फिर let's say there comes a router between you and the person communicating, ARP will not work. But if you are in a lab, for example, ठीक है, तुम college के lab में हो and you are communicating from one PC to another, उस case में there is no router, there is a switch that comes in between. It becomes a local area network, and hence ARP comes into picture. This protocol does not work on bigger network, only local networks, not bigger networks or networks which have router in them. As in router को pass नहीं करता वो, it does not cross the router. ठीक है, to give you the ये सिर्फ यहाँ तक, only to the left side of the router it works, right side it won't. तो अगर यहाँ पे एक और PC होता, the ARP does not work across the router. Next, ARP is a network layer protocol. This is a very important protocol in the TCP/IP protocol suite. Although it is developed in the early 80s, it was defined in RFC 826 in 1982. ARP is implemented with important technologies like IPv4, X25, FAME relay, and ATM. Like I told you, you can check RFCs. These are international documents accepted by everyone in the world. Okay? You'll find it RFC over here. This is the official document. ठीक है? David Plummer. ठीक है? इसमें generally it's either a company, a lab, or the particular people who have found it, who have invented the particular protocol or technology. ठीक है? उनका नाम रहता है. It's like a paper basically. Okay, next. Our protocol finds the MAC address based on IP address. IP address is used to communicate with any device at the application layer, but to communicate with a device at the data link layer or to send data to it, a MAC address is required. When data is sent to a local host, the data travels between networks via IP address, but to reach that host in LAN, it needs the MAC address of that host. Okay? In this situation, the address resolution protocol plays an important role. This point is again important. When the data travels between networks via IP addresses, but MAC address is used when it is local. Okay? In the scenario I just gave you, where here was a PC switch. ठीक है? इस scenario में the data is traveling locally, hence MAC address is required. अगर वो राउटर को क्रॉस करता from network 1 to network 2, then it works via IPs. ठीक है? इसमें I mean anything, any doubt?
No, sir.
Okay, good, right? अच्छा एक बात बताओ, if this locally, sorry, locally data transfer के लिए we use a switch, ठीक है, for across networks we use router, ठीक है, इसमें we have IPs at the network layer and MAC address at the data link layer. Here we have IPs again at network layer, obviously because we need to find वो इंसान कहाँ है. Then how do we go further here? I mean, how do we find in router कि from router to किसको भेजना है? So there was a PC over here, PC1. There is a router and there is another PC. So when sending this to this here, now ARP is not used. So how will I send data? What will be used? Any idea? This hasn't been taught and we don't know, but any general idea?
Sir, layer 3 protocols.
Protocols तो on every layer, but no, like I need to find कि ये कौन है, कहाँ है, वैसा information. Like MAC address gives you physical address एकदम direct ना, unique, वैसा. Okay. So at that level, router uses route table, something called as route table. Router जो device है अपना, जिसमें ये pins वगैरह रहेंगे, उस device पे एक table होता है. ओके उस टेबल पे ये सारी इंफॉर्मेशन है, दिस पीसी टू दैट पीसी, आईपी एड्रेसेस, लिंक्स वगैरह. ओके सो द डेटा इज ट्रांसफर्ड बाय रेफरिंग टू द राउट टेबल. ओके सो if it is locally, then switch and IP and MAC address. Across networks, it is router with IP and route tables. ठीक है, ये बेसिक है. अगेन इसका वर्किंग ऑब्वियसली we have checked about of the ऊपर का लोकली वाला ARP के थ्रू, राउट विल चेक लेटर, बट इन जनरल आइडिया आ गया कैसे चलता है.
Yes, sir.
Okay, this is just theory of what I just told you. Then important ARP terms. So ARP cache, after receiving the MAC address, ARP passes it to another sender where it is stored in a table for future reference, and this is called ARP cache, which is later used to obtain the MAC address. तो ये कैशे कुछ सेकेंड्स का ही रहता है, आई गेस कुछ मिनट्स का, एंड इट कीप्स अपडेटिंग आफ्टर. ठीक है, yesterday ऐसा हुआ था कि माय आईपी एड्रेस चेंज बिकॉज आई स्विच फ्रॉम वाईफाई टू हॉटस्पॉट. तो उस केस में क्या होता है, सो पहले जो था लाइक फर्स्ट माय आर्प कैश टेबल, उसमें होगा एक तरफ आईपी होगा, एक तरफ मैक एड्रेस होगा. सो फर्स्ट इट वाज 192.168.0.1 एंड द मैक वाज AOB9. ठीक है, फिर लाइट चली गई, आई चेंज टू, यहाँ पे था वाईफाई, अब यहाँ पे था हॉटस्पॉट. ठीक है, इसमें चेंज हो गया मेरा आईपी, बिकेम 203 समथिंग फॉर 11. तो इस केस में दिस एंट्री इज डिस्कार्डेड. ओके, द टेबल इज रिफ्रेश्ड, और रिफ्रेश के बाद टेबल में फिर से एक मैपिंग होती है. ओके, इट इज अगेन मैप्ड वेयर this entry is present. Okay, this is the new entry that comes up in the ARP cache table. ARP cache timeout, this is the time in which a MAC address can remain in the ARP cache. So assume कर लो यहाँ पे रहता है for 60 seconds, 1 minute. Okay, in this table the information stays for 60 seconds. After every 60 seconds it will check अभी भी वो ही IP address और वही MAC same है क्या, as in is it mapped to each other. Broadcasting a packet over the network to verify whether we have arrived at the destination MAC address. ARP request मतलब वो जो FF वाली request भेजता है जिसमें source MAC रहता है AOB9, और जिसमें वो डेस्टिनेशन के लिए सारा FF भेजता है. This is called the ARP request. ARP request. ARP request कौन सी रिक्वेस्ट होती है, ब्रॉडकास्ट रिक्वेस्ट होती है. We have trouble कब, ठीक है. ब्रॉडकास्ट रिक्वेस्ट मतलब वो रिक्वेस्ट जो सबको जाती है. ओके, FM रेडियो इज अ broadcast request. Okay, we all are listening to the FM radio and that information is sent to all. Okay, so broadcast request is nothing but a request that is sent to everybody. ARP response and reply, it is a MAC address response that the sender receives from the receiver, which helps in further communication of data. इस था okay, इसका जो reply आता है where source MAC address is now something like AEB1 and destination is AOB9. मतलब पहले इसने AOB9 ने भेजा, रिसीवर को मिला, उसने अपना खुद का मैक एड्रेस भेजा टू द सेंडर AOB9 जिसने उसको भेजा था. ठीक है, कनेक्शन समझा. AOB9 FFF goes to everyone. Okay, उसमें से this person replies back. He replies back with his own address and the destination, because कहाँ जाना चाहिए, reply should go back to the sender, right? इसने भेजा तो रिप्लाई भी इसको जाना चाहिए वापस. Okay, this is the ARP response. Understood? I mean, at least the people who attended yesterday.
Yes, sir.
Okay, good. प्रथमेश तुम तो बाद में आए थे, फिर भी समझा तुमको?
हाँ सर,
क्या
समझ गया
बात है?
था.
Okay. श्रेचा, मोमिता?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, great. Great. Okay. This, the table I've just put in the PPT. Next, Internet Control Message Protocol. Again, this is a theory है इसमें as such example या फिर क्या कहते हैं डेमो नहीं है, so a little bit boring but anyway. ठीक है, तो ICMP v4 Internet Control Message Protocol version 4. It is definitely a network layer protocol and its job is to report the error to the source if any problem arises while delivering the datagram. The ICMP v4 is a message-oriented protocol. It's a protocol of version 4 of the TCP IP protocol suite. So, IP functions in assistance with ICMP report errors. ICMP never gets involved in correcting the errors. Higher level protocols take care of correcting the errors. Every time ICMP v4 delivers an error report to the original source of datagram. The whole idea of this protocol, ICMP v4, is to report errors. So, assuming our previous example, okay, what was it? There was a PC, a switch, another PC, a router, and let's say another PC. PC1 has to send a message to PC3. So message, message, and message. But let's say यहाँ पे एक प्रॉब्लम आती है. What problem? I don't know. Some problem. ठीक है? Because of which the message gets dropped. Dropped का मतलब कुछ नहीं होता, वो just गायब हो जाता है. Like assume कि वो as if something is deleted. Okay, so message is dropped. So PC3 never gets the message and the problem occurred at the router. So what this protocol does is it reports a problem. Okay, it reports problem, not corrects. So it will, and where it does, okay, it sends back report an error report to the original source of the datagram. Datagram matlab message. Okay, datagram is the message. Who sent the message? PC1. तो ये प्रोटोकॉल क्या करता है? ICMP v4 he sends report of error to PC1. वो उसको बोलता है कि ये जो लिंक थी between a switch and the router, यहाँ पे जो लिंक थी, okay, he says that there is some problem over here. What problem is? It also tells what problem is. We'll see ahead. So there are certain codes, certain messages associated with which tells PC what problem actually occurred, right? It is a message oriented protocol. कहाँ पे लिखा था? हाँ, message oriented protocol. तो वो बताएगा कि the code was 1 और 1 code is कि wire खराब है. Okay? या फिर code 2 जिसमें ये बोला था कि राउटर खराब है. कोड 3 where it says कि PC3 अभी switched off है. Okay, so like this it reports errors along with the messages. Is just an example. There can be several reasons behind reporting the error, like a router with a datagram for a host in another network may not find the next router to the final destination host. ठीक है, कभी कभी हो सकता है कि जो एड्रेस तुमने डाला हो वो गलत हो, या फिर वो एड्रेस एग्जिस्ट ही नहीं करता, वो एड्रेस है ही नहीं. ठीक है, इट कैन हैपन मेनी टाइम्स. तो इन दिस केस राउटर के लिए कुछ हॉप नहीं बचा है, देयर इज नथिंग टू गो अहेड, फाइनल डेस्टिनेशन ही नहीं है. ओके, सो दिस कैन बी वन ऑफ द रीजन एंड दिस कैन बी द एरर. फिर डेटाग्राम्स टाइम टू लिव फील्ड हैज बिकम 0. There may be ambiguity in the header of the IP datagram. It may happen that all the fragments of the datagram do not arrive within a time limit to the destination host. Clear? Time to live मैंने कल बताया था. I showed you how it works. Next. Okay. Among these 4 bytes, okay, general form types. ठीक है. Okay, this is the general format of ICMP messages. ICMP messages मतलब जो मैंने अभी बताया था कि टाइप कुछ तो होगा, कोड लेट्स से 1 होगा और डेटा सेक्शन में लिखा होगा कि द प्रॉब्लम इज वायर खराब है. कोड 2 डेटा सेक्शन में लिखा होगा कि राउटर खराब है. ओके, दिस इज हाउ द general format of the message is. There is a type, there is a code, there is a checksum. Let's not get into checksum right now. There is rest of the header and data section. Our main focus is type, code and data section. Okay, so among these 4 bytes, the first 4 bytes कैसे हुए बताओ? 4 bytes कितना होता है? और rather 1 byte कितना होता है?
8 bit.
Good. ठीक है, so the first byte describes the type of the message. The second byte clarifies the reason behind the type of the message. The next 2 bytes define the checksum field of the message. The rest 4 bytes define the rest of the header, which is specific for each message type. The data section varies according to the type of message. अब header अलग अलग होते हैं अलग अलग protocols के लिए. The way we saw in network layer कि there is a source IP, destination IP, there is a TTL, there is others. Yeah. That is how a header is. In ICMP, the header might be different. Okay. Next. Types. So there are 2 types. One is error reporting messages, one is query messages. The error reporting messages data section holds the information to identify the original datagram that has an error. The data section of the query message holds more information regarding the type of query. तो अब समझ में आया इसमें क्या था? Okay, so error reporting messages का data section, इस data section में अगर type of message error reporting message है तो it identifies the original datagram that has an error. The data section of the query message, अगर query message होगा तो उसके data section it will hold the message regarding the type of query, मतलब क्या problem है वो बताएगा. It is further divided into these categories. ठीक है, error reporting में there are 5 messages type of. एक destination unreachable, source quench, time exceeded, parameter problem और redirection. Query message में there are 2, echo request and reply, timestamp request and reply. Error reporting messages. ठीक है, so we are now in error reporting messages और उसके 5 categories we will see. Error reporting messages. The most important function of ICMP v4 is to report the error. Although it is not responsible to correct the errors, the higher level protocols take care responsibility of correcting the errors. ICMP v4 always sends the error report to the original source of the datagram. As the datagram has only two addresses, source address, destination addresses, so ICMP v4 uses the source address for reporting the error. Why source address? क्योंकि जिसने मैसेज भेजा था उसको वापस ये एरर के बारे में बताना है. ICMP v4's job is to report the error back to the source address. Okay. It says the higher level protocols take care of responsibility of correcting the errors. तो for example इसके higher इसके ऊपर क्या है, TCP IP है. अगर मेल होगा तो POP वाला, then there is SNMP and such protocols which are at higher level which will fix the error. ICMP's job is to report it. ठीक है, ये डिफरेंस समझ में आया? Okay. There are some important characteristics of the ICMP v4 message. Message is not generated in response to error messages as they can create infinite repetition. Okay. मतलब error reporting के इसके लिए और एक मैसेज नहीं होता. Like for example an acknowledgement. ठीक है कि हाँ भाई मुझे मेल मिल गया. There won't be any such message. Okay. The error message does not generated for the fragmented datagram if the fragment is not the first fragment. You can ignore this point. Okay. Yeah. ICMP error messages is not generated for the datagram having the special address 127.0.0.0 वगैरह. ठीक है. इसमें APIPA address should also be there. It is a problematic address. Even if ICMP v4 does not report it, it is considered to be a problematic address and the network should be troubleshooted. ठीक है. Next, this message is not generated for the datagrams with the broadcast address or multicast address in the destination field. So if you send a broadcast request or the destination में broadcast address हुआ तो you will not get an error message because this is not sent to a particular device. It is sent to all. So error reporting नहीं होती because I mean you can imagine कितना प्रॉब्लम होगा, कितने मैसेजेस होंगे if there is error and at each level for each device. Okay. ब्रॉडकास्ट एड्रेस कैसे आइडेंटिफाई करते हैं?
सर 255 से एंड होते हैं.
नहीं ऐसे थोड़ी है. अगर मैंने सबनेट मास्क चेंज किया तो उसके हिसाब से है ना वो.
लास्ट में सब वन ही होगा except
Yeah,
subnet
one,
mask.
but there is another
Then
important term
uh,
for it between it. There are two important terms. उसमें से एक है कि all ones. That's true. What is the other important term in that identification? Ones
so
in the
होस्ट पोर्शन में
except
वंस होते हैं सारे.
yes. So all ones is correct, but in host portion is important. Okay. Both these terms go hand in hand together, and in order to identify a broadcast address, it should be all ones in the host portion. So there may be some addresses जिसमें नॉट नेसेसरीली 255 ही हो, ठीक है, एंड में, और या फिर सारे वंस ही हो एंड में. Okay, the host portion is important. So as if the subnet mask changes, the host portion will change, and उस case में it can either be network, it can either be host, or it can be broadcast depending on how the combination sets in. Okay, next. Reporting messages, ठीक है. How much is there? Okay, now we are in this, we are in error reporting messages destination unreachable category, ठीक है. So consider if a host or a router is unable to deliver or route the datagram, then they discard the datagram and send a destination unreachable error messages to the above source host, right? ये एग्जाम्पल में हमें कहाँ प्रॉब्लम आया है, यहाँ पे प्रॉब्लम मैसेज ड्रॉप्ड in this router. Okay, so that is why what did we get? We got that destination is unreachable, error message to the source host. So there are three types: code is 0 to 15, this checksum, this unused, IP header plus first 8 bytes of datagram. Okay, this is the format of destination unreachable format. The destination host generates the destination unreachable message with the code as 2 or 3, and the router generates a message with the rest of the codes. I have it here, you find it on your own. अगर तुम्हें नहीं मिलता है, then I will send you this Word documents. It's very easy. A simple Google search will give you all the codes. ठीक है. If I want to show you example, this is the host is unreachable as the precedence was cut off, port unreachable, protocol unreachable, and etc. ठीक है. So find out what the codes are and what the messages are. Again, this is for personal knowledge. So the destination host generates the destination unreachable error messages with the code as 2 or 3, and the router generates a message with the rest of the code. So code 2 or 3 is by the destination host, and router generates the other codes. Let's see if we can try. Okay, so if I say ping, let's pick a random host. See, destination host unreachable. Okay, but what is this 101? Let's try to see what this 101 is. Non-existent domain / all. ठीक है. Anyway, okay, so this is some device, most probably a router. ठीक है, तो मेरा मैसेज क्या गया? ठीक है, it went from my PC, मेरा ये PC था, उसमें लिखा ping 192.168.0.5. ठीक है, अब क्या करता है, ये मैसेज गया मेरे राउटर के पास. ठीक है, अब राउटर क्या करेगा, इट विल स्टार्ट लुकिंग फॉर दिस एड्रेस. ठीक है, मेरे पीसी का एड्रेस वाज क्या था, पीसी एड्रेस वाज 101. my PC address is 101. okay, so my address reply from the PC is destination host unreachable, because वो उसके आगे कभी गया ही नहीं. ठीक है, so I have a smartphone जिसका होगा 0.4, then I have a laptop जिसका होगा 0.3. so and router is not there, consider I don't have a switch at home, so it's a router के through connections आ रहा है. ठीक है, it the message came here and it started looking for this IP, लेकिन किसी का भी IP वो नहीं है, it is not found. So what it says host unreachable, And where did the message come from? From 101, which is my PC itself, because it never went ahead. Okay. Another scenarios, let's say PC, one router, two router, and then some host. Okay. इसका है 101, इसका है 123. Okay. If I say ping 104, वो है क्या यहाँ पे? नहीं. But the point is कि it crosses this and the problem comes over here. कोई नहीं है. तो अगर इसका address 201 होगा, so what will be the reply? Reply from, कहां पर प्रॉब्लम आया? यहाँ पे 201 पे. From 201 that host is unreachable. ठीक है. Right now my, क्या कहते हैं, my laptop address is 101. The problem is here itself because ये laptop के आगे कुछ है ही नहीं. There are no devices. ठीक है. That is why it is destination is unreachable. It doesn't even go to the router because कहीं और जाने के लिए है नहीं उसको. ठीक है. But in this scenario, let's say my PCs and there are two routers and then there is my smartphone, laptop and so on. ठीक है. तो यहाँ से मैसेज गया and problem आया second router पे 201 पे. So then it will say reply from 201 that host is unreachable. That's how you identify कि problem कहाँ है एक network में. ठीक है. So you found out कि इस पूरे नेटवर्क there are two problems. One, कि there is nothing as 104. There is no host as 104 in this network. This is important. ऐसा नहीं कह रहा हूं कि दुनिया में कहीं भी नहीं है या फिर तुम्हारे घर के बाहर नहीं है, ऐसा नहीं. इस पर्टिकुलर नेटवर्क में नहीं है. एंड प्रॉब्लम कहाँ पे आया है? यहाँ पे, इस राउटर पे. मतलब यहां तक मैसेज सही से जा रहा है. मैसेज तुम्हारे लैपटॉप से निकलता है, यहाँ पे सही से जाता है, उसके आगे भी जाता है, बट यहाँ पे प्रॉब्लम आता है. ठीक है. इसका मतलब इस राउटर को it has an entry of 104, so he sends it to another, but there is no entry over here because he does not know कि 104 कहाँ पे है. कहीं तो है बट इस नेटवर्क में नहीं है. That's, मैंने निकाल दिया क्या? Okay. Let's take some other, sorry. Now if I take absolutely too much of random, for example, ठीक है, रिक्वेस्ट टाइम्ड आउट आता है. नाउ द रीजन यहाँ पे होस्ट अनरीचेबल नहीं आया क्योंकि मैं उस सबनेट में ही नहीं हूं, मैं उस नेटवर्क में नहीं हूं. ठीक है. जो मैंने पहले मैसेज भेजा था ना, आई वॉज इन द सबनेट, आई वॉज इन द नेटवर्क. मेरा पीसी कहां पे है? इस नेटवर्क में है. इट इज इन दिस नेटवर्क. तो इसीलिए जब मैंने ये वाला आईपी एड्रेस डाला, इसने दिया होस्ट अनरीचेबल क्योंकि इट इज इन स्टिल इन द सेम नेटवर्क, अभी भी उस नेटवर्क में है. तो मेरा इस एग्जांपल में, सो माय मैसेज इज इन द सेम नेटवर्क, इट जस्ट डजंट नो कि ये होस्ट वहां पे है और नहीं है बोलता है. बट अभी जो मैंने डाला 172 168, वो तो इस नेटवर्क में भी नहीं है. इट इज सुपर रैंडम. ठीक है. वो तो इस नेटवर्क में भी नहीं है. दैट इज व्हाई वी गेट द एरर रिक्वेस्ट टाइम्ड आउट. ठीक है. कोई डाउट? if I again I'll show you. If I say 192.168.0.56, see, this is the difference. This is absolutely out of the network. This is within the network, but there is no such thing as .56. There is no host. ऐसा कोई डिवाइस ही नहीं है जिसका ये 56 क्या कहते हैं आईपी है. Okay, understood?
Yes, sir.
हाँ. And destination host unreachable to 56 मतलब इसका मतलब ये नहीं कि आईपी एड्रेस है नहीं, इसका मतलब I cannot reach out to 56. क्या पता वो मेरे एरिया में बाजू वाली गली में किसी के घर के किसी का पीसी का ये आईपी एड्रेस है. द मीनिंग ऑफ दिस इज कि वो आई कैन नॉट रीच आउट टू हिम. मेरे लैपटॉप से मैसेज बाहर जाता है लेकिन वो उसके आगे जा ही नहीं सकता है क्योंकि इसकी एंट्री ही नहीं है कहीं पे. ठीक है. सो माय राउटर डज नॉट नो 56 बट in general over the internet it is somewhere and I cannot reach out to it. ठीक है. Next, again we are under still error reporting messages and we are at source quench. The source quench error message informs the source that the datagram has been discarded due to the congestion in the router or destination host. Time exceeded. Every datagram has a field of time to live which decrements by 1 every time it visits a router. Again, ये कल मैंने बताया था कैसे वर्क करता है. There are two reasons to send the time exceeded message to the source host, which is defined by 0 or code 1. ठीक है. So when this time to live field decrements to 0, the router discards the datagram and sends a time exceeded error message to the originating source of datagram. If the destination host doesn't receive all the fragments of the datagram in a set time, then it discards all the fragments and sends a time exceeded error message to the origin host. Just okay. Time exceeded wala. It's hard to show you a demo because सबका time to live अलग होता है. Generally, default is 16. Some have 120. Some have whatever default. So if I cannot find a destination जो उसके पहले उसके exceed हो, like 16 से ज्यादा हो, this error message won't come. ठीक है. But जैसे I show you how destination unreachable वाला example, वैसे ही इसका भी आता है. You'll get an error message stating कि it is too far. ठीक है. Time to live 0 हो गया. मतलब वो जिसको तुम मैसेज भेजना चाहते हो वो तुमसे 10 राउटर से भी ज्यादा आगे है. ठीक है. और उस उतना मैं दूर जा नहीं सकता या फिर मैसेज उतना दूर भेज नहीं सकता. सो एंड सो व्हाटएवर द रीजन, in that reason it says time has exceeded, the time to live has exceeded. Okay. Then parameter problem. Okay, we are still here. Reporting messages, parameter problem. If the destination host or the router find an ambiguity in the header of the IP datagram, then they discard the datagram and send a parameter problem error message to the originating source of the datagram. Ambiguity as in same रहा, there is no uniqueness, कुछ you know similarities रही जिसमें distinguishable नहीं है datagram, so it will send a error message to the source IP address or the source host of the datagram. ठीक है. It is type 12, code will be 0 or 1 and check some IP header plus first 8 bytes of datagram so and so. This is the basic format. Code 0 defines that there is an ambiguity in the header field. Okay, I thought मैंने नहीं लिखा है but I have. So Code 1 defines that there is ambiguity in the header field of the datagram and the pointer field's value points to the byte of the datagram header which has a problem. Defines that the required part of the header is missing. Here the pointer field is not used. So अगर कोड 0 होगा तो वो exactly कहाँ पे प्रॉब्लम है ये बताएगा in the datagram header. यहाँ पे IP header plus first 8 bytes of datagram. 8 bytes मतलब 64 बिट्स हुआ. ठीक है, तो एग्जैक्टली कहाँ पे प्रॉब्लम है ये कोड 0 बताएगा और कोड 1 बताएगा कि हेडर्स में कुछ पार्ट मिसिंग है, बट एग्जैक्टली क्या और कहाँ पे दिस विल नॉट बी टोल्ड. हु विल टेक केयर ऑफ दिस एरर? द हायर लेवल प्रोटोकॉल्स. An example of higher level protocol is TCP/IP. उसके ऊपर POP3 if it's a mail, SNMP, ICM, there are a lot. ठीक है, I don't know कितने हैं total, but there are many. Reporting messages, redirection. Okay, the last type under reporting messages, it is redirection. ठीक है, तो a router sends a redirection message to the local host in the same network to update its routing table. The router here does not discard the received datagram. Instead it forwards to the appropriate router. ठीक है, type 5 code 0 to 3 and so on. ठीक है, अगर कोड 0 होगा तो redirects for the network specific route. कोड 1 होगा तो redirects for the host specific route. However, the message with the code 2 redirects to the network specific route for a specific type of service. Code 3 redirects for the host specific route for a specific type of service. Just remember this definition. Codes and all is not expected. As in, you are not expected to remember this, but what each type is, categories, at least that much, at least the definition is expected to know or remember. ठीक है, a router sends a redirection message to the local host in the same network to update its routing table. मतलब वो मुझे इस एग्जांपल में जैसे यहाँ पे था, यहाँ पे हमें प्रॉब्लम आया था सेकंड राउटर पे, तो वो क्या बोलता है कि ये राउट सही नहीं है, मुझे मेरे पास ऐसा कोई भी डिवाइस नहीं है 104 वाला, सो प्लीज अपडेट द राउटिंग टेबल. इट अपडेट्स द राउटिंग टेबल सेइंग कि ऐसा कुछ है नहीं, और जिसके पास होगा उसके इसमें राउट अपडेट होगा एंड ही विल बी एबल टू सेंड द मैसेज. ठीक है, it does not discard the received datagram, instead it forwards it to the appropriate router. तो यहाँ पे कोई प्रॉब्लम नहीं था 104 के लिए इस राउटर के पास, मतलब इस दिस राउटर हैज इंफॉर्मेशन, सो इंस्टेड ऑफ डिस्कार्डिंग द मैसेज इट सेंड्स बैक द मैसेज टू दिस राउटर स्टेटिंग कि भाई 104 मेरे पास तो नहीं है, so I will update my table, you also update your table with the information, and if you have 104 then whatever the message is supposed to do. ठीक है, so it is network specific and host specific. Query messages. ठीक है, now we come to query messages. There are two types: echo request and reply, time request and reply. ठीक है, we'll see this in some time. Let's take a break. ठीक है, let's come back in 10 minutes. 10:55 को we resume. Is everyone here?
Yes, sir.
Okay.
Yes, sir.
Yeah. Prathamesh, I guess we'll end with your presentation of forwarding based on label. बहुत ज़्यादा theory वैसे भी
Okay,
हो.
sir.
So let's see your presentation and then we'll end.
So should I present right now?
Yeah.
Okay. So is it invisible?
Mm, not yet. It's just a white screen. रीशेयर करो एक बार. सिर्फ ब्लैंक वाइट स्क्रीन आ रहा है.
So, uh, so is it visible?
Yeah, now it is.
So good morning all. The topic is label-based forwarding. And so label-based forwarding is a technique where network routers make IP forwarding decisions which are based on the label attached to the packet rather than the IP address. So the label-based forwarding is primarily used in MPLS, which is multi-protocol label switching, to speed up the data transfer and ensure efficient traffic engineering across the large networks. So the multi-protocol label switching was originally developed in the 1990s to enable high-speed network connections for the enterprise networks. It began as a proprietary protocol and was standardized by the Internet Engineering Task Force in 2001 as RFC 3031. So IP packet process. So it is a traditional process in which the router needs to forward the packet to another router, and there are three basic steps for this. So first, the router looks within its routing table for the best match for the destination route. Then the router checks if there any special treatment, for example, transmission priority or queuing that must be applied for the traffic. Then the router will send the packet to the necessary next hop IP address via the appropriate interface. So then the packet is forwarded across the network with each router performing the steps above. So this was not the optimal method for packet forwarding, especially with the ISPs which have extremely large routing tables. So this is where the MPLS comes in handy. So uh, what is MPLS? So MPLS is a switching mechanism which is based on labels. This switching works as the MPLS label being pushed or inserted into the packet between the layer 2 and layer 3 headers. So each router along the path then switches the packet based upon the uh, label and the relating information which is stored within the label information base. So this indicates any hop by hop IP lookups from occurring that we have within the traditional IP routing process. So the key point about the label information base is that it is pre-calculated and it only contains the input label along with the output label and interface. So the computation required for to forward the packet is greatly reduced compared to that of traditional IP routing process. So this is the MPLS header where the MPLS label is placed between the layer 2 and layer 3. The header contains a label uh, which is 20-bit long and can take the value between 0 and 2 raised to 20 minus 1. The EXP, which we can call as experimental, they are 3 bits long and used for quality of service. Then the bottom of then there is the bottom of stack. It is size of 1 bit and MPLS labels are stacked over other. So if there is only one label remains, then its value is 1. Otherwise, it is 0. Then the time to live, it is 8 bits long and its value is decreased by 1 at each hop to prevent the packet to get stuck in the network. So the forwarding process in the MPLS. So LSR, which are the label switch routers. Those who can understand the labels. So they receive the IP packet from the CA, that is customer edge routers, and add an MPLS header between layer 3 and layer 2. So that means it encapsulates the link layer, that is layer 2 frames. So this allows the LSRs to support receiving packets containing frames from different protocols. So the MPLS forwarding is based on label attached to the IP packet. This label attachment is regulated by a protocol called Label Distribution Protocol. So it is a protocol which automatically generates and exchanges labels between the routers. After that, each LSR initially learns the routes as normal routers too. So this is the learning starts with the provider edge routers, which are the we can say edge which are present at edge of the MPLS network that can add or remove label from the IP packet. Uh, then suppose we can say uh, the provider edge routers, which are which are at the edge of the MPLS network, learns to route to the subnet one, or we can say to the customer one in the below diagram. So PE1 will add the label to packet forward to its neighboring LSRs, which are in the MPLS network, and tells them that if you receive the packet with destination address to subnet 1, forward it to me. This process is
Can you
repeated
this
by this
point?
LSR.
Your voice got cut off.
Okay, sir. So should I repeat or what?
The
Hello?
point which you were saying right now. Just repeat it.
Okay. So this process is repeated by the LSRs which are in which, the LSR which is connected to the customer one, and uh, if uh, uh, if if LSRs receives the packet from the neighboring LSRs, it tells them if you receive the packet with destination address to subnet 1, then forward it to me. So this process is continuously repeated, and in this way the LSR learns routes to add this information in the label forwarding information base, that is LFIB. So if any provider edge routers receive the packet with destination to subnet 1, then it will look at the labels, and LFIB and LSRs can easily forward the IP packet. So the pros and cons of MPLS are, so the pros are it is dynamic, scalable, and versatile with better performance and better bandwidth utilization, and they also reduce traffic congestion as compared to traditional IP routing. The MPLS is also have a secure transmission mode for data packets, and it is not easily vulnerable to DOS attacks. MPLS also supports traffic isolation and creation of virtual private networks, and VLANs or VLAN services and virtual lease lines. The cons are MPLS is a mechanism in which that needs to purchase a carrier frequency to use network. So because of that, it is more costly than the transmission, which can be accomplished through public network. Then next is it is difficult to find MPLS service provider for global coverage service, which can be costly and time consuming. Then MPLS was designed multiple branch offices receive and send traffic back to main headquarters or data centers. It is not suited where branch office directly want to access the data available on the cloud. Thank you.
Okay. Thank you, Prathamesh. So one of the point was important key. It is mostly used by companies and it is expensive, difficult. वो router पे सब set करना पड़ता है, configuration changes करने पड़ते हैं. So it's a headache. So it is good for companies but not for us. So your home internet would not have it. ठीक है. तो उसमें particular एक कोड होता है, टाइप होता है जो उसमें लगता है, फिर वो राउटर पे चेंजेस करने पड़ते हैं कि अगर कोई ऐसा पैकेट आता है जिसमें ये कोड हो, डेटा लिंक लेयर पे, ईथरनेट लेयर पे, ठीक है, ऐसा कोड हो, वैसी वायर में उसका ये हो, अलाउंस हो, तो ही एक्सेप्ट करना, वरना मत करना. लाइक फॉर एग्जांपल सपोज द कोड इज ईथरनेट प्रोटोकॉल होता है, ईथरनेट प्रोटोकॉल का सपोज कोड इज assume any random number, let's say 5. तो राउटर पे पहली बात तो वो राउटर वैसे मैन्युफैक्चर्ड होना चाहिए, अगर है तो उस पे सेटिंग्स में देयर शुड बी एन ऑप्शन टू अलाउ पैकेज that have a ethernet type of, let's say, code 5. Only then it will be allowed. Our home routers are not equipped for that. Okay, so that's an important point. Generally mostly you'll find it in companies and you won't find it for general purpose use. Okay, we'll go through the query messages next time. There has been a lot of theory for today, so I think yeah, query messages, I meant the ICMP v4 protocol ke query messages. We'll go through them next week. Okay, that's it for today. Prathamesh, send your this assignments, the 2 of them. Okay, send it today. Shubham, you can still send your forwarding based label and IPv4, IPv6 assignments. Okay, since they were given last week, send these 2 assignments on mail. Your presentation will do next week, so yours and Asha's.
So actually next week we will have an exam.
Oh, sorry, right, my bad.
So what
So
is the
portion के
syllabus for first term?
Okay, I have prepared the question bank. I'll share it to you today itself. First thing, portion will be this till the last part that I have taught. Okay, so today's itself. So हमने कहाँ तक सीखा? Let me make it to you. Wait.
Okay, please share some notes or PPTs with us.
Yeah, just a second. Okay. I will confirm PPT ka, but the assumption for up till now was that you refer to the recordings, but I will check about the PPT. I mean, there's no problem, obviously, but let me first see what the college has decided. Regarding portion, till year, till ARP, okay? ARP हमने जो सीखा, ठीक है? तब तक it will be this. 2 days you can skip, ठीक है? It is neither in the
Okay, sir.
question bank nor will be asked in exam. So till ARP protocol, address resolution protocol, the portion will be there, 1 to 40. ठीक है? Question bank mail पे, ठीक है? I will send it. I'll send the question bank to you guys on mail.
Okay, sir.
Okay. Yeah. Other than that, yes. So assignments, Asha, your forwarding base label is remaining. Prathamesh, your forwarding and IPv4 versus IPv6 is remaining. Please send
Sir,
this. Yes.
sir, I have mailed you my forwarding
Mila.
based on,
Yes. Mila.
but
Okay.
only presentation is remaining, sir.
ठीक है, आप क्या ही कर सकते हैं. नेक्स्ट वीक अगर एग्जाम्स हैं, both weekends are going, Saturday, Sunday.
Yes.
No, sir, we have exam on only Saturday, not Sunday.
Okay. And what about the next week after that? Do the exams
So,
still go on?
yeah, this Saturday and when is coming Saturday and next Saturday.
Okay, so next Saturday, that would mean October, wait, October 5, right?
Yes, sir.
Okay, so Saturday 28 is gone, October 5 is gone. ठीक है, at least submit कर दो. Asha, yes, I have got your mail. Found it. Shubham's is pending. ठीक है.
Sir, so should I present it on next Sunday if Saturday's class is scheduled on Sunday?
ठीक है, अभी तक मुझे तो कोई ये नहीं आया कि वेदर संडे को क्लास. सो सैटरडे ऑब्वियसली एग्जाम के लिए वी वोंट हैव अ क्लास. संडे का आई डोंट नो. इफ वी हैव अ क्लास, यस, प्रेजेंट इट. इफ वी डोंट, आई
Okay,
मीन
sir.
नेक्स्ट टाइम देखते हैं. आई
Okay,
हैवंट
sir.
प्लान्ड सो मच अहेड. ठीक है. Okay, I'll send the question bank immediately right now after call. Thank you. That's it for today.
Thank you, sir.
Thank you, sir.
Thank you, sir.